giving you 8 thousandths. Come down here and it shows you 8 thousandths wide 3-dimensional tolerance zone. So that part can be 8 thousandths. It still has to be 45 degrees, but it can be 8 thousandths total. So 4 thousandths bottom and top is what it's showing within that same tolerance zone. However, it has to adhere to the 45-degree angle. This slide is a really good slide that talks about position. Sorry. So here we're at 1 thousandths within 5 thousandths, so it's showing, or one inch plus or minus 5 thousandths. So kind of what we talked about earlier, it can be off a little bit, correct? So this is the Cartesian coordinate tolerancing, plus or minus there. This is your position tolerancing, pretty close to the same thing. Okay. Here's the one that I want you, that's kind of confusing at first. So you have a square box, okay? It's a tolerance zone as far as a square. So it's giving you 10 thousandths on the top side. Make sure that we're looking at the same one before I walk up there. It's giving us 10 thousandths tolerance is allowed here, 10 thousandths here. Maximum tolerance is 10,000 times 1.4. Now why is that? Because it's what it's saying is that you can be anywhere within that zone and you're still within tolerance. However, the measurement across that cube is greater than 0.1. It's actually this times 1.4142 is the correct dimension. So your tolerance can also extend into this portion as well. So you cannot, in this case it's a square dimension, it's only giving you 2. And what it's telling you, a lot of times if you're outside of that up here, you might say, well, I'm not there here. If we measure from here to here, it's 10, but this is actually going to be 14. Okay? Let me help try to make sense of that. It doesn't do a very good job of explaining that. So let me break it down real quick. Okay, so here's your square box. And we're going to make it very simple. This is 1 inch, 1 inch. Now it's saying your tolerance zone is 1 inch, correct? So if we have a center point right here in the middle, and we took this measurement, say we did a radius portion off of it, if we took it here, see if I can do this. Not very successful. If we did from here to here, it would be in this direction. That would be your 0.10. Or, sorry, your 1 inch tolerance is from here to here. So you'd be doing a 1/2 inch radii. Here to here is 1/2 inch. But that's not what it's saying. With the square dimension, you can be here and still be within tolerance. Well, to find this dimension at 45 degrees, you take your dimension and multiply it times 1.4142. So if this is 1/2 inch, let's make it simple again. This is 2, 2. So our radius is 1. This dimension from here to here is going to be 1.4142. So what happens if we were to make this direction? That's a different circle, correct? However, we are technically in spec if we would be out here on a round tolerance level versus the square one is not. Okay. Here's the diameter tolerance zone. This is an increase of 57%. So you can see that's it. All it's showing is that it's a lot larger than this one, which is exactly what I did with the outside diameter circle on the box that I just drew on the board. Okay? All right. Some position feature control frames. The diameter symbol and tolerance amount indicate the diameter of the tolerance zone. Letters A, B, and C are reference datums. Okay? So let's look at these two. We're going to kind of float back and forth real quick. All right. Let me find in your book where this also shows you as well. We are on page 228. Okay. So what this is going to show us, let's refer to this picture and this print. Our position, we're at a 1/2 inch plus or minus 2 1/1000ths. Okay, so we can be out of round, we could be somewhat ovaled. However, the position needs to be within the diameter 0.04. So real quick, that shows us that our max material position, our whole diameter, can be the whole diameter can be 0.498, but the tolerance zone diameter is 0.004. And this is just a good introduction to some GD&T. It can be rather tricky from time to time to work through. All right. Work through this on your own. Do some practice exams here at the, work yourself through the review questions at the end of the chapter. Come see me for the test. Thank you. We appreciate your time. Oh, sorry. Let me not finish yet. Real quick. We talk about circular runout. Okay? So this is really important. We're talking about putting a dial indicator on here. So when we say circular runout, would be at 0.002 of an inch. So if we were to set this up on a V block and we were to rotate it around, essentially we would not want this to be out of round more than 0.002 of an inch. Okay? It needs to be within the direct dimension. If it's 0.002 greater, your dial indicator will show it. That's just how you set up. So you would set this way, and when your high spot comes around, it'll read it. But your low spot comes around, it'll read the opposite direction as well. You will be doing some of this within the machine shop. Get a good example of doing this as well. Okay, I want you to read through this portion also. You have a tolerance zone here where it can go be within 0.002 top or bottom. And this, you know, when you start dealing with the industrial maintenance portion of this as well, you will have a tolerance on this. You will also have a end shaft tolerance to where it can only come out and move so far. Bearings can have different tolerances, whether depending on what type of bearing, what type of gear it is as well. So we will get very familiar with dial indicators and precision measurement devices going through the program. All right, now thank you. If you have any questions, please come see me. Have a good day.